Imagine having a machine in your room that can create almost any object you can dream up. I'm not talking about carving something out of a block of wood, but literally building it from nothing, right before your eyes. It's like watching a ghost draw on the air with melted plastic, or seeing a laser fuse powder into a solid shape. Layer by painstaking layer, an idea on a screen becomes a real physical thing you can actually hold. It sounds like something straight out of science fiction, right? Well, it's not. It's happening right now.
So, how in the world do we get from a simple digital file to a solid physical object? Well, we're going to break it all down. We'll start with the core concept, then look at the tools and the wild world of materials, and finally, we'll explore how this technology is already building the world of tomorrow.
Okay, so to really get a handle on 3D printing, you first have to understand the one big idea that makes it so radically different from how we've made things for centuries. It completely flips the script on manufacturing.
It really does seem impossible, doesn't it? But the secret isn't some kind of magic trick. It's all about taking our traditional idea of making things and turning it completely upside down.
And this right here, this is the key. For basically all of human history, we've practiced what's called subtractive manufacturing. You take a block of something, wood, stone, metal, and you cut, carve, or drill away everything that isn't the final object. Think of a sculptor. 3D printing is the exact opposite. It's additive manufacturing. You start with nothing and you add material, layer by tiny layer, building up to the final shape. The best part? There's almost no waste.
Now you might think this is some brand new futuristic tech, but its roots actually go all the way back to the 1980s. Pioneers like Chuck Hull and Scott Crump developed the core technologies that we still rely on today. But back then, this was not a toy for hobbyists. Oh no, this was a serious industrial tool for something called rapid prototyping. And a single machine, it could set you back more than the cost of a house.
Okay, so we know it builds things by adding layers. But how does an idea on your computer screen actually become a physical object you can pick up? It's a surprisingly simple three-step journey.
Yeah, it really just boils down to these three things. First, you model it. You create a digital blueprint using CAD software. Then, you slice it. And this is crucial. You use software to break that model down into thousands of super thin digital layers. And finally, you print it. The machine just reads those layers and builds them, one on top of the other. Now, that slicing step, that's the real magic translator. It takes your 3D model and converts it into a special language called G-code. You can think of G-code as the printer's own personal DNA. It's an incredibly precise instruction manual that tells the machine every single coordinate to move to, how fast to go, and what temperature to use for every single layer.
But here's the thing you have to remember. 3D printing isn't just one single thing. It's more like a whole toolbox filled with different technologies, and each one has its own clever way of building those layers.
So this chart breaks down the three most common types. You've got FDM, which is the one you probably picture in your head. It works kind of like a super precise robotic hot glue gun, melting plastic filament and drawing with it. Then there's SLA, which is all about precision. It uses a UV laser to harden liquid resin, and you get these incredibly detailed objects with a glassy, smooth finish. And then there's SLS, an industrial beast that uses a high-powered laser to fuse tiny particles of powder, like nylon or even metal, together into a solid part. And when you get to the truly industrial scale, the technology gets even crazier. We're talking about processes like direct metal laser sintering, which can print incredibly strong, surprisingly lightweight parts from powdered titanium or steel. These aren't just trinkets. These are mission-critical components for companies like SpaceX and GE. Now, if you thought the methods were cool, just wait until you hear about the ink, the materials you can actually print with. The range today is just astounding. This is where the possibilities really start to get wild. We have come so far beyond just simple plastics. I mean, sure, you can print with the same stuff Legos are made of, but today's printers can also work with super strong carbon fiber, high-grade metals, and even ceramics. You can print with filaments that are filled with real wood particles, you can print entire houses out of concrete, and yes, you can even print custom desserts out of chocolate.
But this is probably the most mind-bending material of all, bio-ink. Scientists are now experimenting with printing structures using actual living human cells. They're laying the groundwork for a future where we might be able to 3D print replacement organs for transplants. Just let that sink in for a minute.
So this is obviously way more than just a tool for hobbyists, right? This technology is actively, and in some cases profoundly, reshaping our world in very real ways. So let's talk about why this matters right now.
You can see right here where it's making the biggest waves. Healthcare is by far the largest adopter. They're using it to literally save and improve lives. Aerospace and the auto industry are using it to make travel safer and way more efficient. And even construction is finding revolutionary new ways to build things.
And look, this isn't some far-off future concept. This stuff is happening today. Medical devices like prosthetics and dental implants are being custom printed to perfectly fit a specific patient. Jet engine parts are being designed with these insane internal structures that make them lighter and stronger, which saves a ton of fuel. There is a fully functional steel bridge in Amsterdam that was entirely 3D printed. A bridge.
So if all of this is already happening, where does it go from here? I mean, as incredible as this technology is, it's still evolving. Let's take a quick look at the challenges and the really exciting stuff on the horizon.
Like any game-changing tech, it's not perfect. The advantages are huge, insane levels of customization, creating complex shapes you couldn't make any other way, and almost zero waste. But there are still hurdles. Printing big stuff can be painfully slow. A lot of parts need some cleanup work like sanding or curing, and there are some really big questions around things like intellectual property and safety.
But even with those challenges, the momentum is just undeniable. The market is projected to absolutely explode, hitting $84 billion by 2029. That's not just growth, folks. That signals a fundamental shift in how we make, well, everything.
And this quote gets to the really big idea, the one that could change everything. Imagine you need a spare part for your appliance. Instead of waiting weeks for it to ship from a factory overseas, you just download the file and print it at a local shop, or maybe even right there in your own home. That's the vision. Manufacturing becomes distributed, local, and completely on demand.
When you think about the potential to print habitats on Mars using Martian soil, or to democratize manufacturing so anyone can be a creator in their own garage, you realize the possibilities are just starting to take shape. The next layer of our world is being printed as we speak. So the question is no longer if our future will be printed, but what we will choose to create with this incredible power.